Okay, we're going to make a start now. So, welcome everyone to our GCSE Maths session. In today's lesson, as we've already stated, we're going to be looking at Pythagoras' theorem. Okay, we're going to go through the content, we're going to look at some example questions, and then you're going to have a go at some questions yourself, and then we're going to move on to some exam style questions that you would expect to see whenever you're sitting an exam. Okay, I've also added in a few sort of more difficult questions for anyone who wants to challenge themselves, but I'll mention them as we progress through the lesson. If you guys have any questions at any point, just let me know in the Q&A. The questions which are on topic and linked to the question, I will answer. But the ones that aren't sort of related to the question or the topic that we're discussing, I'll leave till the I'll do an open Q&A at the end of the session. Okay. Um, Before we start, I just want to make this clear that for Pythagoras' theorem, this is a foundation and higher topic. So you would expect to see questions on Pythagoras' theorem on a foundation paper and a higher paper. There are some applications that we will go through, but all of this lesson is applicable for both foundation and higher students. Okay, so we're going to start off now. And this is our first sort of lesson on this sort of subject area, Pythagoras' theorem, and then we're going to be moving on to trigonometry and sort of harder trigonometry um, topics over the coming weeks. So, first of all, if we start off by looking at Pythagoras' theorem is used to work out the length of a missing side in a triangle. So we know that in a triangle, we normally have three sides. Okay, we have three sides, and sometimes we don't know the length of one side. For example, we may not know this length over here. We might know this length, for example, 5 and 6, but we might need to work out this length labeled x. And that's what Pythagoras is for. If we know the length of two sides in a triangle, what will happen is that we can work out the length of an unknown side. Okay, and that's why Pythagoras' theorem is useful. Okay, it's only applicable for right angle triangles. Just remember this. This is the key fact that you need to remember, that it's only applicable for right angle triangles. So triangles that have a right angle within them. So it's applicable for triangles such as this, not triangles like this where there is no right angle, or sort of triangles like this where there is no right angle. There are no right angles in these two triangles. There is a right angle in this triangle. That's why it will work for these triangles. Okay, so just remember this sort of formula that we're going to see now is only going to be applicable for right angled triangles, triangles which have a right angle within them. Okay, and there's a key word that you need to get used to, and that is the hypotenuse. And whenever we have a Pythagoras question coming up, you will always have to label the hypotenuse of the triangle. And there's a simple way to do that. The hypotenuse is the longest side in a right angled triangle. It is the side which is opposite the right angle. Okay, and we're going to have a look at some examples in a minute. But if we have a look at this first example, first of all, we've got a triangle. As you can see, we have a right angle over here. And because we have a right angle, we know that we can use Pythagoras' theorem. Okay, so that's number one check. We can use Pythagoras' theorem because this triangle is a right angle triangle. Second step is we need to label the hypotenuse. Now, the hypotenuse is the longest side in the triangle. Okay, so from this triangle, you can see that this side over here is the longest side in the triangle. And that's why we label that side as the hypotenuse. You can also think of it like this. We've got the right angle over here. Okay, this is our right angle. The hypotenuse will always be opposite to the right angle. Okay, so if we know where the right angle is, we can draw an arrow opposite the right angle, and that side will be our hypotenuse. So in this case, the hypotenuse is a side which is opposite the right angle, the longest side in the triangle. Okay. So all we've done now is we've just gone over Pythagoras' theorem, solved the content wise. We're going to get introduced into a formula, which is not too difficult at all. We're going to have a go at labeling a triangle, and then we're going to move on to some examples. Okay, so key takeaways from this slide. Pythagoras' theorem can only be applied to right angle triangles. If you don't have a right angle in your triangle, then you can't use Pythagoras' theorem. Okay, it has to be a right angle triangle. Secondly, you have to label the hypotenuse. The hypotenuse is the longest side in the triangle of a right angle triangle, and it's always the side which is opposite to the right angle. So in this case, I've drawn the right angle there. The side opposite it is the hypotenuse. Now, if we move on to looking at some triangles, as we do over here, um, in this first example, this is our right angle. Okay, this is our right angle. This is our right angle. This is our right angle. And this is our right angle. If we were to label the hypotenuse, it's literally the longest side in the triangle, okay, or the side which is opposite the right angle. So in this case, because the right angle is over here, this is our right angle, the side opposite it is our hypotenuse. So that is our hypotenuse over there. Okay, we have our right angle over here. So the side which is opposite it over here, this is now the hypotenuse. Okay. That's our hypotenuse there. And we're just going to label it with a H because it's high, H for hypotenuse. Over here, we've got our right angle over here. We've spotted our right angle. The side which is opposite it is going to be our hypotenuse. So we're just going to label hypotenuse there. And then finally, in this triangle, our right angle is over here. So the side opposite it, the longest side in the triangle, is over here. So we're just going to label that with H. Okay, and that's how you spot the hypotenuse. The hypotenuse is the longest side in the triangle, and it's the side which is opposite to the right angle. So if you can't spot the longest side in the triangle, spot the right angle, and it's going to be the side which is opposite to the right angle. Okay, so that's how you go about the first step of any Pythagoras question, spot the hypotenuse. Check if it's a right angle triangle. If it is a right angle triangle, spot the hypotenuse and label it. Okay. Now the next thing that we need to go through is what Pythagoras' theorem, what the formula actually is. And this is the formula. Okay. And trust me, we'll look at an example and we'll go step by step. Okay. Pythagoras' theorem, note down this formula, is a squared plus b squared equals c squared. That's Pythagoras' theorem. Okay. That's what Pythagoras' theorem is. A squared plus b squared equals c squared. A and b are the two shorter sides, and c is the hypotenuse. So if we have a look at these triangles over here, the hypotenuse, wherever we've labeled the hypotenuse, we also label that as c, because c is the longest side. Okay, we also label that as c, just like that. And then the two shorter sides, we can label as a and b in any order. Okay, so we can label that as a, and this one as b, A and B, A and B, A and B. So it doesn't really matter. And this will make more sense when we look at an example. Okay, but all you need to know is this formula at the moment. A squared plus B squared equals C squared. Okay, A and B are the two shorter sides, C is the hypotenuse. So whenever you get a question with a triangle and you need to use Pythagoras' theorem, check if it's a right angle triangle, label the hypotenuse, label A, B, and C. So there are three sides and there are three letters. So you're going to label each of the sides with the letter A, B, and C. The side that you've labeled the hypotenuse with, that is automatically going to be C. And the two other sides, the two shorter sides, can be labeled A and B in any order. Okay, and I'm going to go through an example now. Okay, and then I've got one question for you guys to have a go at as well. Okay, so we'll work through this example together, and then I'll hand over to you guys and you can have a go at working out the next question. So over here, number one, first step, we're going to check if it's right angled. Okay, we're going to check if the triangle is right angle, and as you can see, we've got a right angle over here. So we're going to say that we can use Pythagoras on this triangle. Okay, the second step is going to be label your hypotenuse. Okay, so how do we label our hypotenuse? Well, it's the side which is opposite to the right angle. So if we have the right angle over here, the side which is opposite to the right angle, which is literally, I've drawn an arrow opposite to the right angle, we're going to label that as our hypotenuse. The third step is going to be label A, B, and C. So remember, in this formula, we had A, B, and C. Okay, so we had A, B, and C. A squared plus B squared plus C squared equals C squared. And remember what I said about C. C has to be the longest side. Okay, and the longest side is the hypotenuse. The longest side is the side which is opposite to the right angle. Okay, so what we're going to do is we're going to label the hypotenuse as C, because remember, C is the longest side. Okay, and then the other two sides can be labeled A and B in any order. Okay, so I'm just going to label this as A and this as B. Okay, so I've labeled the sides, labeled A, B, and C. The fourth step is going to be write out the formula. Write out and substitute into formula. So if we have a look at this case, we know that Pythagoras' formula is a squared plus b squared equals c squared. Okay, we know what a is. Okay, a is 3. So all we're going to do is we're going to, instead of a, we're going to write 3. Okay, instead of a, and we've got the squared there. Then we've got add b squared. What's b? Well, b is 4 because we've labeled b as 4. So we're going to replace the b for a 4, okay, and square it. And that's equal to c. And we don't know c. We need to work out the hypotenuse. It says calculate the hypotenuse. We need to work out c. So we're going to leave c as it is. Okay, so that's equal to c squared. Okay, we can work out what 3 squared is. 3 squared is just 3 times 3. So 3 times 3 is 9. Okay, and then we're going to add 4 squared. What's 4 squared? 4 times 4 is 16. So we've got 9 at 16, and that's equal to c squared, which we need to work out. Okay, 9 at 16 is 25. Okay, you can work that out. 9 at 16 is 25. So we know that 25 is equal to c squared. Okay, we need to work out what c is. Okay, remember, c is the same as the hypotenuse, and we need to work out the hypotenuse. We want to work out what c is. At the moment, it's being squared. C is being squared, and that's giving us an answer of 25. Okay, but we don't want c squared. We want just c. So to get rid of this squared on this side, we need to do the opposite. The opposite of squaring something is square rooting it. Okay, so what we're going to do to get rid of this c squared, so we have c squared equals 25. To get rid of this 2, all we're going to do is square root both sides. Okay, so then we're going to be left with c is equal to the square root of 25. And the square root of 25 is just 5. Okay, so we get that c is equal to 5. Okay, and if you want to check your answer, a way to check it is basically that because we're working on the hypotenuse, we know that the hypotenuse is the longest side in the triangle. So your answer must be bigger than what A is and what B is. So we know that A is 3 and B is 4. So our C should be bigger than 3 and 4. And our C is 5, so we know we are correct. Okay? So before I give you an example to go through by yourself, I'm going to quickly run through this just to clarify any misconceptions. Follow these steps over here from top to bottom and you will be fine. Check if it's a right angle triangle. If it is a right angle triangle, label the hypotenuse. Once you've labeled the hypotenuse, label A, B, and C. C will be the hypotenuse. A and B are the two shortest sides in any order. And then you write out the formula and you substitute into the formula. Okay, so we know that A is 3 and B is 4. So over here we substituted A is 3 and B is 4. And C is the one we needed to work out. 3 squared was 9. 4 squared was 16, and that was equal to c squared. 9 at 16 gives you 25, and that's equal to c squared. But we don't want c squared. To work out just c, all you need to do is get rid of this squared. And if you're probably thinking, why did we square root over here? If we're adding, the opposite is subtracting. If we're multiplying, the opposite is dividing. If we're squaring something, the opposite of it is square rooting that same thing. So over here, c squared equals 25. To work out c, we need to square root the other side. Okay, and we square rooted 25, and we got c is 5. Okay. Okay, I will explain step 4 again, just because it's on this question, before I give you one to go through. So over here, when we went through step 4, all we did, we wrote out this formula over here. We wrote out this formula. Once we wrote out the formula, we had our sides labeled A, B, and C. We know that A was 3, and we know that B was 4. And in our formula, we had A and B. So all we did, in place of A, we wrote the number. Okay, so in place of A, we wrote 3. In place of B, we wrote 4. Okay, so we wrote 4 there. And that was equal to c squared because c is the hypotenuse. C is what we need to work out. Okay, c is our question mark. Okay, so we had 3 squared. We simplified that to 9 because 3 squared is just 3 times 3, and that's equal to 9. So we had 9. 4 squared is just 4 times 4, which is equal to 16. And we had 9 plus 16 equals c squared because c is what we need to work out. 9 at 16 gives you 25. So we've got 25 there, and that's equal to c squared. And we want to work out what c is. We don't want c squared. We want to work out what c is. To work out what c is, we need to get rid of this squared. C is being squared at the moment. We don't want it to be squared. So all we've done is we've done the opposite. Okay, because it was being squared, we did the opposite of it, which was square root. Okay, so we square rooted the opposite side. So we square rooted 25. Square root means just two numbers which multiply together to give that number. So two numbers which multiply together to give 25, which are the same, is 5. That's why we get that c is equal to 5. Okay, so hopefully that makes sense. I'm going to move on now to give you guys one to have a go at yourself. Very similar question, and sort of same concept. Okay, I'm going to give you guys 2 minutes to have a go at this question, and then I will go through it with you. Okay, and you can let me know your answers in the Q&A. And if you guys are struggling at any point, just let me know which point you're struggling with. Okay, so how do you know which one is A and which one is B? Okay, it doesn't matter which one is A and B. You can label it in whatever order that you want to. Okay, it doesn't matter which side you label as A and B. It matters which side you label C, but it doesn't matter which side you label A and B. Okay, you can label either side as A and B. Okay, 30 seconds, everyone. Okay, I'm seeing a lot of answers come in. Okay, I'm gonna go through the answer now. Okay, so I think everyone over here has got 15. For anyone that's not got an answer, don't worry. I'll go through it now. Okay, so again, step one, it says calculate the hypotenuse. So we know that, first of all, check, is it a right angle triangle? Okay, yes, it is a right angle triangle because we can see our right angle over here. Okay, that's our right angle. Step two is going to be label the hypotenuse. Okay, so we're going to label our hypotenuse, and the hypotenuse is going to be the side which is opposite to the right angle. Okay, so our right angle is over here. The side which is opposite it is going to be the hypotenuse. Okay, so this is our hypotenuse. We've labeled the hypotenuse. Let's write out our formula. Our formula is going to be a squared plus b squared equals c squared. That's our formula. We're going to label A, B, and C. And remember, C has to be the longest side in the triangle. C has to be the side which is the hypotenuse. So we're going to label this side as C, and then A and B can be the other two sides in any order. It doesn't matter which order you label them in, but the other two sides can be A and B in any order. So I'm just going to label this as A, and I'm going to label this as B. Now what we're going to do is we're going to substitute in our numbers into the formula. So we had this as our formula over here. We know what A is. A is 12 centimeters as we have it over here. So instead of A, we're going to write a number in. We're going to write in 12 because that's what we've worked out, 12. And we're going to square it. Add B squared. B is 9 over here, as you can see. So instead of B, we're going to write in 9, and then we're going to square it, and that's equal to C. C is what we need to work out. We don't know what C is, so we're going to leave C just like that, C squared. Okay, now 12 squared is the same as 12 times 12, and 12 times 12 is 144, just like we have there. And we've got 9 squared. 9 squared is just 9 times 9, and 9 times 9 is 81. So we're going to add 81 to it just like that, and that's equal to C squared, which we still don't know. Okay, now 144 add 81, that's gonna give you 225. Okay, 145 to 81 gives you 225. You can work that out, and that's equal to our c squared, which we still need to work out. Okay, so we know that c squared is equal to 225. Okay, but we don't want c squared. We want just c. And remember what I said before. Opposite of add, subtract, opposite of multiply, divide, opposite of squaring something is square rooting that same thing. Okay, so we don't want this squared. This squaring is being annoying right now. Okay, we don't want it. Okay, so to get rid of it, we're going to square root the other side. Okay, so to find out what c is, we're going to find the square root of 225. And the square root of 225 is 15. Okay, so you would get c equal to 15. Okay, and that is your answer. And because we're calculating the hypotenuse, we know that's the longest side in the triangle. To check our answer is correct, we know that this number must be larger than the other two sides. This is 12, this is 9, this is 15, so we know our answer is correct. Can you get this question on a non-calculator paper? So this question you can get on a non-calculator paper because you should know from the top of your head that the square root of 225 is 15. Okay, just because 15 is sort of a midway number, it's a good number to have, and the numbers that you are working with are not too difficult as well. Okay, so you can definitely get this on a non-calculator paper. Okay. Okay. But how can you calculate the square root? So the square root, you can't really calculate the square root. It's just something that you should know from the top of your head. Like of if I said the square root of 100, you will know that as 10. And the square root of 225, they expect you to know it from the top of your head as well, because the answer is a good number. The answer is 15. Okay? Because it's a good number, you're basically required to know it from the top of your head. If it was a really sort of odd number, for example, the answer was 17. If you had something like the square root of 289, that would be on a calculator paper, because you're not required to know that from the top of your head. But 225, you will be required to know from the top of your head, because it gives you 15, which is a good number. Okay, so it's one of those numbers which you're just required to know. Okay, now I'm going to run through this example, and then I've got another question for you guys to have a go at, and then we're going to move on to some exam questions. Okay, so the only difference with this question is that you know the value of the hypotenuse. Okay, it says calculate the length, which is labeled, and I'm going to label it. This is the length that we need to calculate, what I've labeled as x. But the concept that we're going to go through is the exact same. Okay, so step one is going to be label hypotenuse. Okay, now if we label the hypotenuse, okay, if we label the hypotenuse, we know that our right angle is over here. Okay, the right angle is over here. The side which is opposite it is going to be the hypotenuse. So we're going to label that as h. Okay, that's the hypotenuse. So we've labeled the hypotenuse. Second step is we are going to write out the formula, and we're going to label A, B, and C. Okay, so we're going to write out formula plus label A, B, and C. Okay, so our formula is going to be a squared plus b squared equals c squared. Okay, that's our formula. Okay, we need to label A, B, and C. And we know that C has to be the side which is the hypotenuse. So we know that this side has to be C, because the side opposite it, the side opposite the right angle is the hypotenuse, that has to be C. And then the other two sides can be A and B in any order. Okay, so it can be A over here and it can be B over here. It doesn't matter which order that you put in, you just need to make sure that C is over here. A and B can be placed in any order. Now, third step is going to be substitute into formula. So you're going to substitute the numbers into the formula. Okay, so we had A squared plus B squared equals C squared. We know that A is 12, so we can replace A for 12. So instead of A, we're going to write 12. So we've got 12 squared. And then we've got B squared. Now B is over here. B, we don't know. B is X. So we're just going to leave B as it is. Okay, because we don't know it. Okay, so we're going to add B squared because we don't know what B is. And that's going to be equal to C squared. Okay, now C, we know what it is. It's 13. So instead of C, we're going to write 13. Okay, so we've got 13 there. And we're going to square it. Okay, now this is the same exact concept. 12 squared is the same as 12 times 12. That's going to give you 144, just like we have there. And then we're going to add b squared because we still don't know what b squared is. We need to work out what b is. And that's equal to 13 squared. Okay, so 13 squared is just 13 times 13. Again, you can work out without a calculator by doing column multiplication. 13 times 13 is going to give you 169. Okay, now over here, we need to work out what b is. Okay, at the moment, it's being added to 144 and it's being squared. So how are we going to do this? Well, first of all, we need to get all the numbers onto one side, and then we need to get all the letters onto one side. Okay, and to get all the numbers onto one side, follow the key trick. do the opposite. Opposite of addition is subtraction, opposite of multiplication is division, opposite of squaring something is square rooting that same thing. Okay, so if we have a look at this example, 144 at b squared equals 169. Okay, we want b squared by itself. So let's get rid of this 144. At the moment, it's being added to b squared. So to get rid of it, you have to do the opposite of it. You're going to have to subtract 144 because it's being added onto b squared. And whatever you do to one side, you must do the same to the other side. So you're going to subtract 144 from this side. And 144 subtract 144 is going to give you 0. So that gets rid of that 144. And then you're left with just b squared on this side. And then 169 subtract 144, you can work out again, is going to give you an answer of 25. Okay, because 169 subtract 144 over here gives you 25. And 144 subtract 144 gives you nothing. Okay, so we're left with b squared on this side, and on the other side, we're left with 25. Okay, so we know that b squared is equal to 25, but we don't want b squared. We just want b. And at the moment, it's being squared. So to get rid of that squared, we need to square root. As I said over here, to get rid of a squared, we need to do the opposite, and we need to square root that same thing. So we would need to square root 25. So we would get b is equal to the square root of 25. Therefore, b is equal to 5. Okay, and this answer must be smaller than your hypotenuse because we're given the hypotenuse. The hypotenuse is 13. So we know that our side must be smaller than 13. And we got 5. So we know we must be correct. Okay, so before I give you an example to have a go at yourself, just running through the key detail again. If there's any steps that you guys don't understand, let me know. Step 1, same thing, label hypotenuse. Step 2, write our formula, same thing. Step 3, substitute into the formula, same thing as before. The only difference that we have is that we need to rearrange in this case, okay, because we don't know the middle B or the A. Okay, and to do that, just follow these golden rules. You need to get all the letters to one side, so the B to one side, and you need to get the numbers onto the other side. So we had 144 plus B squared equals 169. And to get rid of it, the 144 was being added to b squared. So to get rid of it, we must do the opposite to it. Okay, so the opposite of adding is subtracting. So we're going to subtract 144 from this side. 144 subtract 144 gives you nothing. And when you're subtracting from one side, you must do the same to the other side. So we subtract 144 from the other side as well. 169 subtract 144 gives you 25. We're left with b squared on this side, and then the same concept. We don't want b squared, we just want b. Okay, so we do the square root of 25, and we get that b is equal to 5. Okay, just explaining step 4 again. Okay, no worries. Over here is just a substitute part. Okay, so we've got a squared plus b squared equals c squared. We substituted our numbers. Over here we had 12 and we had 13 over here. So we know that a was 12, so instead of a we write 12. Instead of c we write 13. Okay, b we don't know, so we leave b as that. Okay, 12 squared is the same as 12 times 12. That gives you 144. Plus b squared, which we need to work out, we don't know what it is. And that's equal to 13 squared, which is 169. Okay, now if we have 144 plus b squared equals 169, we want the b to be on one side and we want the numbers to be on the other side. So we're going to get rid of this 144 and move it to this side. How are we going to do that? Follow these rules. Opposite of add is subtract. At the moment, as you can see, 144 is being added to b squared. But we don't want the 144 there in the first place, so we're going to do the opposite of it. We're going to subtract 144. And whatever we do to one side, we must do to the other side. We're going to subtract 144. And then that's going to give us 169 subtract 144. That's going to give us 25. So we get that b squared equals 25, just like we have there. And then to work out b, we need to get rid of the squared. So we square root the other side. So we square root 25. And the square root of 25 is 5. So we get that b is equal to 5. Okay, so hopefully that makes sense. A question for you guys to have a go at now. For this question, you can use a calculator. Okay, Okay, guys, I'm just going to give you 2 minutes and then I'll go through the answers. If you're struggling, please let me know what part you're struggling with, or if you have any questions, let me know. I'll be answering them in the Q&A. Okay, just one more minute, guys. Because the question doesn't specify, you can just leave it to how many decimal places you wish. 1 or 2 decimal places should be fine. Okay, 30 more seconds and then I'll go through it. Okay, I'm going to go through the answers now. So we're getting a lot of similar answers. So well done, everyone. Okay. So calculate the length label. So step 1 is going to be find the hypotenuse. Hypotenuse. So we've got our right angle over here. Okay, this is our right angle. And then the side which is opposite to the right angle is going to be our hypotenuse. Okay, so that's our hypotenuse. Step 2 is going to be label A, B, and C. So we've got a squared plus b squared equals c squared. That's our formula. So if we're labeling our sides, we know that c has to be the same side as the hypotenuse. So this is going to be c. And then a and b can be the other two sides in any order. Okay, so it's going to be, I'm just going to label a there and b there. And this is x by 3. Okay, because that's the unknown side. Okay, step 3 is going to be substitute. Okay, so we have our formula, which is a squared plus b squared equals c squared. That's our formula. And then we know what a is. A is 18. So instead of a, we're going to write 18. So we're going to write 18 instead of a, and we're going to square it. And then we're going to add what b is. B we don't know. So we're going to leave b as it is because we don't know what it is. So we're going to have b squared still, and that's equal to c squared. Now c, we know what it is. C is 47. So instead of c, we're going to write 47. Okay, so we're going to just write 47 squared. Okay, now again, you can use a calculator for this. So 18 squared gives you 324 plus b squared, which we still don't know, so we're going to leave it like that, b squared, and that's equal to 47 squared. 47 squared is 2209. Okay, now step 4 is going to be rearrange to work out b. Okay, so we had 324 plus b squared equals 2209, which is there. We want b to be by itself. We don't want this plus 324. That's being annoying right there. So we're going to get rid of it. Okay, so the opposite of add is subtract, opposite of multiply is divide, opposite of squaring something is square rooting that same thing. So at the moment that this 324 is being added, so we're going to do the opposite of it to both sides. We're going to subtract 324 from both sides. So we're going to subtract 324 from this side, and then we're going to subtract 324 from this side. Okay, 324 subtract 324 gives you nothing, so that gets rid of that. 2209 subtract 324 gives you 1885. Okay, that it gives you 1885, and that's equal to whatever we're left with on this side, which is just b squared. Okay, now we don't want b squared, we don't want this squared, we just want to work out what b is. So the opposite of squaring something is going to be square rooting the other side. Okay, so to work out what b is, we're going to square root the other side. We're going to square root 1885. Okay, 1885, and that's going to give us an answer of 43.4. Okay, and I've just left it to one decimal place. Okay, obviously the question didn't state, so it doesn't really matter. In an exam, they will state how many decimal places you need to list it to. Okay, so I've just listed it to one decimal place. Okay, moving on. Now, this is sort of a more challenging question to have a go at, and we had some sort of different types of exam questions to go through, but I think it would be worth just ending on a slightly more difficult question, rather than looking at these exam questions, because these exam questions are the exact same as the ones that we've already looked at. The examples that we've looked at, they're in the same format. So to finish off on a high note, we'll have a look at this question. Okay, now I'm going to give you guys 3 minutes to have a go at this question. Okay, now you have to work out the volume of this triangular prism. Okay, and again, this is suitable for both foundation and higher, because finding volume is a topic that foundation also cover. Okay, but if you get this question, this would be right at the end of a foundation paper. Okay, if you're struggling, don't worry, work step by step. Think about what you need to work out the volume of a triangular prism. Okay, and I'll give you a clue for those who are struggling. To work out the volume, you need to work out the area of the triangle, and then you multiply by the depth. Okay, and how do you work out the area of a triangle? You need to do base times height divided by 2. Okay, so I've purposefully put this question as like the last example because it's one of the more difficult questions. If you're struggling with it, don't worry, I will go through it. Okay, guys, just one more minute. We're seeing a range of answers over here. Okay, I'm gonna go through the answer now. Don't worry if you didn't get the correct answer, because this is set to challenge. Okay, okay, okay. I'm gonna go through it now. Okay, and this is probably sort of in an exam style question that you would get towards the end of a paper. Okay, so it says find the volume of this triangular prism. In order to work out the volume of the triangular prism, what do we need to know? We need to know the area of this triangle. Okay, so I'm just gonna highlight this area of the triangle. Okay, so this is our triangle that we have over here. In order to work out the area of that triangle, we need to use base times height divided by 2. Okay, base times height divided by 2. That's how you work out the area of the triangle. Okay, so this is our base and this is our height. Okay, however, we don't know what our base is. We need to work out what the base is. Okay, how do we work out that? Well, we know that this length over here is 65 centimeters. Okay, that means that this length is also 65 centimeters. Okay, because it's a rectangle. Okay, if this length is 40 centimeters, we must know that this length is also 40 centimeters. Okay, so we need to work out that link that if this is 65 centimeters, then the side which is opposite here is also 65 centimeters because it's a rectangle. Okay, now we can use Pythagoras' theorem to work out what the base is. So if I draw this triangle out again, we have this triangle, the right angle is there. We know that this is 25. We know that this is x. That's the side that we need to work out. Okay, and we know that this is 65. Okay, we know that is 65. Okay, so we know it's a right angle triangle. We have two sides, so we can work out the length of the unknown side. How do we do that? Well, again, Pythagoras. A squared plus b squared equals c squared. This is our right angle, so the side opposite here is our hypotenuse. Okay, that is also c. Okay, because the hypotenuse must be the same as c. And then a and b can be labeled on the triangle in any order. So we'll just label this as a and this as b. Okay, so we've labeled a and b. Now all we're going to do is we're going to substitute in to the formula what a and b is. Okay, so we know that a is 25, so instead of a, we're going to write out 25. So we've got 25 squared plus b. B we don't know. B is x. We don't know what b is, so we're just going to leave b as it is. And that's equal to c squared. We know that c is 65. So instead of c, we're going to write down 65. Okay, so 65, and we're going to square it. Okay, now you can use a calculator for this. 25 squared is 625. So we've got 625 plus b squared, because we still don't know what b is, and that's equal to 65 squared. Now 65 squared is equal to 4,225. Okay, now from here, same concept, we want b by itself. Opposite of add is subtract, so all we're going to do to get rid of this plus 625, we're going to do the opposite of it. So we're going to subtract 625, and whatever we do to one side, we must do the same to the other side. So we're going to subtract 625 from this side. 625 subtract 625 is nothing, so that gets rid of that. 4,225 subtract 625 is going to give you an answer of 3,600. So we know that b squared is equal to 3,600. Now we don't want b squared, we want just b. And the opposite of squaring something is square rooting that same thing. So we're just going to find out the square root of 3,600. So b is going to be equal to the square root of 3,600. Therefore, b is going to be equal to 60. Okay? So over here, our base that we've just worked out, that's 60. Okay, so we've worked out what the base is. The base is 60. Okay, now we can work out the volume because we can use this formula. The area of the cross section is just the 2D shape. The 2D shape is a triangle. So the area of the triangle multiplied by the depth. The depth is how much through the shape that it goes. There is a full lesson on sort of working out cross sections and volumes as well. But this is sort of an application to Pythagoras. That's why I've decided to include it to challenge you guys to apply your knowledge on Pythagoras. Okay, so height base divided by 2. So to work out the area of the triangle, we're just going to do 25 multiplied by 60, the height multiplied by the base divided by 2. That's what you're going to type in to your calculator. Okay, so we're going to have 25 multiplied by 60 divided by 2 is going to give you an answer of 750. Okay, and then we need to multiply it by the depth. Okay, so we're just going to multiply by the depth, this value over here, which is 40. So we're going to have 750 multiplied by 40. And again, type that into your calculator. That's going to give you an answer of 30,000 centimeters cubed. Okay, so that's how you find the volume of this triangular prism. Okay, so all we did was we worked out the base, okay, because you needed to know this formula over here, and you are required to know this formula. Area of a triangle multiplied by depth gives you the volume of the triangular prism. We didn't know the base, so we worked out what the base was by using Pythagoras. We knew that this was 65, so that means this value must have also been 65. Okay, and then we draw our triangle over here, and we used Pythagoras to work out what the base was. Okay, so we worked out the base as 60 by doing Pythagoras, and then we worked out the area of this triangle over here. 25 times 60 divided by 2, that gave us 750. And then all we did was we multiplied it by the depth. Okay, so the depth was 40, so we just did 750 multiplied by 40, and that gave us this answer, 30,000 centimeters cubed. Okay. And for today's lesson, we're going to consolidate there. We've gone through all the content of Pythagoras' theorem, the different types of questions that you could be faced with, and we've also ended off with a challenge question. We didn't have sort of time for exam questions, but again, if you look at these questions, it says calculate the length of AB. AB is literally this length over here. You would know how to do that because it's literally the first type of example that we looked at in today's lesson. So again, the examples that we looked at in today's lesson were very close to what you would get in a typical exam as well.